All right, everybody, welcome back to part 2 of the ionic bonding and naming presentation. Now we're really going to talk about how to name these compounds. You're always going to have a positive ion that joins with a negative ion to make a neutral compound. So how do you name it? So it's called binary ionic nomenclature. Binary means there's two ions that are going to come together. And nomenclature, nomen means name. And so this is how we name these compounds when we put the positive and negative together. So you always write the positive ion first, and you write the negative ion second. Remember, on your periodic table, you definitely want to have your periodic table handy during this presentation so that you can be following along. Anytime that I'm referencing my periodic table, you should be looking at it and maybe even pausing the video to make sure you understand. So just to keep in mind, the positive ions are the ones that are always going to be over on this side, and the negative ions are the ones that are going to be on this side. So the positive ions come first, the negative ions come second. The charges have to add up to 0. We want a neutral compound when we're done. And so that's gonna determine how many of each ion you need. And this sounds dumb to have it written here. We're never going to use prefixes. And you're like, KJ, I didn't know we were ever going to use prefixes. We don't use prefixes with ionic compounds. We do with covalent compounds, which you might not have learned about yet. So just be aware of that's a difference between ionic and covalent compounds. Okay, and it says the ending of the second element is always switched to IDE, IDE. So we'll do some practices on that right now. So if we have chlorine and it bonds with potassium, the first thing you want to do is find chlorine and potassium. Try to follow along. This one's pretty easy. So potassium is right here. It needs to lose one electron in order to be like a noble gas. And chlorine is exactly on the opposite side, and it needs to gain an electron in order to be like a noble gas. So chlorine is going to be the negative, and potassium is going to be the positive. So how do you write it? Do you write it ClK or do you write KCl? And the answer is KCl because potassium is the positive element. So how do we write the name itself? How do we say it? We don't just say KCl, although sometimes when I get lazy, I do. Potassium chloride. Notice that we changed the word chlorine to chloride. So that's a way of sort of signifying this is an ionic compound when it ends in IDE. Okay, let's try just a slightly trickier one here. This is magnesium. Magnesium bonds with bromine. So find magnesium. Magnesium is in our second group. That means that it needs to lose 2 electrons in order to be like a noble gas. So magnesium is going to form a +2. Bromine, on the other hand, let's find bromine. Give me just a second. Bromine is right here, and it just needs to lose 1 electron. So bromine is going to form a -1. So we know that magnesium is the positive one. So we know magnesium is going to come first. How did they decide that it was MgBr2? We'll get to that. So what's the name? We just write the name magnesium bromide, and we're going to learn about where that 2 comes from. We call that a subscript. If you write a small number up above, like the charges, that's a superscript. And if you write a small number down below, that's a subscript, like a submarine. All right, so crossing the charges to determine the ionic compound, just like we were talking about a moment ago. Okay, if the charges of the ions are the same, so you have a +1 and a -1, then the ratio is 1 to 1. Whenever there's a 1, you don't have to write the subscript. So strontium and sulfur come together. So strontium is a +2, strontium is a +2, and sulfur is a -2. So that's strontium sulfide. It's just SRS, done, nothing to it. When it becomes difficult is when you have an element that has either multiple plus charges or multiple minus charges, and that's when we're going to have to cross them. So it says, if the charges of the ions are different. Hey, by the way, if you have a +2 element and a -2 element, you don't have to write anything. If you have a +1 element and a -1 element, you don't have to write any subscripts. When I say you don't have to write anything, I mean you don't have to write any subscripts. They cancel each other out. You just need one of each, and you never have to write the number 1. Okay, but what if we have an element that's a +2 and another element that's a -1? You've got 2 plus charges here, and you've got 1 minus charge here. you have to have a neutral compound. So we've got 2 pluses and 1 minus. How many minuses do we need in order to cancel out these 2 pluses? Well, we need another minus, and then they would cancel each other out. We'd have 2 pluses and 2 minuses, and they cancel each other out. So it says if the charges of the ions are different, then the ratio, the subscripts, can be determined by crisscrossing the charges. Now, here's the problem with crisscrossing the charges. Crisscrossing the charges, I'll teach you how to do that in a second, is a cheat. It's a trick. And sometimes students just learn the cheat and they don't understand why it works. So let me just show you really quickly why it works. And then you can do the cheat all the time, but you really need to understand why it works, because it'll come up later when I'm trying to test your understanding of what you're doing. Okay, so it says what compound will form if Mg, magnesium, and fluorine combine? So magnesium, if you find it again, it's in the second column. So magnesium is a +2 and fluorine is in the second to last column. So it's a -1. So it says determine the charges of the ions by looking at the periodic table. Mg is a +2 and fluorine is a -1. So what you should be doing, this is the not cheat. This is the real way to do it. You should ask yourself, how many fluorine atoms with a -1 charge does the compound need to balance the +2 charge of the magnesium so the ion is neutral? Well, we're going to need 2 fluorines and 1 magnesium. Notice 2 and 2, we have 2 negatives and 2 positives. They cancel each other out. Our charge is neutral. Okay, so that's how we're supposed to ask ourselves. But you're going to see something that's kind of cool. Watch what happens. You write Mg and it's a +2 as a superscript, and the fluorine is a -1 as a superscript. You don't ever have to write these. This is how the cheat works. And then you move them diagonal. We call it crisscrossing. So now you're going to put the 2 down by the F and you're going to put the 1 down by the Mg. Now here's the part where students start to misunderstand. They start to write +2 by the fluorine and -1 by the magnesium. Nope. That the subscript is telling you how many magnesiums we need and how many fluorines we need. You should never write a plus or a minus next to the subscript. It's just a number. We need 1 magnesium, or we need 6 magnesiums, or we need 3 fluorines. You don't have a plus or a minus by the subscripts. So cross them, but then don't write the charges. And then notice that you never write the 1. So we had fluorine was a -1, but you made magnesium you didn't write the 1 by it. It's just we need a 1 magnesium. And then the magnesium was a +2, and you put the 2 by the fluorine because we needed, magnesium was a +2 and fluorine was a -1, and we needed 2 fluorines to cancel out that 1 magnesium. All right, let's try a few others. We're going to do a lot of examples to practice this, and that's what your homework is going to be as well. Okay, transition metals. You should have written transition metals already on your periodic table. They basically make up the middle part of your periodic table, all the way over to the metalloids. It's hard to do this backwards. La, 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 la. I can't do backwards. So it says transition metals are from group 3 up to the dividing line, the metalloids, that cuts through the P section. Remember that these metals have electrons in overlapping energy levels. So remember that if you look on your periodic table, it's hard to do this backwards, but like this is 1, 2, 3, 4. So this is 4s. Potassium is 4s1, 4s2, but then it's 3d1. And then if you go all the way across, then it's 4p1. The 4 and the 3 are overlapping. That's what they call them, as overlapping energy levels. And that makes the transition metals weird. They don't follow any of the rules. So we're going to do some special stuff with those transition metals. Because of this overlap, the atom is often trying to fill 2 different levels instead of just 1. This means that transition metals will often have more than 1 possible charge. In the written name of a compound, the transition metals will have a Roman numeral that follows its name. Will you take a moment right now and turn your periodic table over? There we go. And find on it all the different elements that have Roman numerals by them. And notice that they often have more than 1 Roman numeral. So look for iron. Find iron there. You have iron 2 and iron 3. And right below it, you have lead 2 and lead 4. So it says it'll have a Roman numeral by it, and that's going to tell us its charge. So lead 2 has a +2 charge. Lead 4 has a +4 charge. So the Roman numeral designates the charge. The Roman numeral does not need to be written in the molecular formula. So when you write iron, which is Fe, you do not need to put a Roman numeral by it. But when you write the name, you do have to write the Roman numeral. We'll make that make sense in just a second. So let's try iron 3. So it's got a +3 charge, and it bonds with chlorine. You don't really need to look it up, but you can see it right here. So here's iron 3. The reason you don't need to look it up is because I told you it's a +3 charge. So we know it's iron 3 because that's the one that has a +3 charge. On the other side, just to remind you, chlorine is going to be a -1. So we've got iron with 3 pluses, try and get this in there, and we've got 1 chlorine with 1 minus. How can we neutralize these 3 pluses? Well, we need to have 3 chlorines with a -1 charge, and then they neutralize each other. So it says iron bonds with a +3, so that means iron is going to be written first. Let's cross the charges. So iron is a +3, chlorine is a -1, cross them over. And so we would get FeCl3. And how do we write the name? Well, we need to indicate, see how the molecular formula doesn't tell you which iron it was? We need to say that in the name. So it's iron 3 chloride. So it doesn't matter that there's 3 chlorines. That has nothing to do with it. Just plain old chloride. Let's try another one. Copper with a +1 charge. You could find it here again. Copper comes as a 1 or a 2, but we're telling you it's +1, so we know it's copper 1. And it bonds with oxygen. Oxygen is a -2, everybody. It needs to go 2 over in order to be like a noble gas. It needs to gain 2 electrons. So copper is going to be a +1. Oxygen is going to be a -2. We're going to cross the charges. Copper is written first because it's the positive. It's the cation, and oxygen is the anion. Notice that we've crossed the charges and we get Cu2O. Now be careful. Copper is copper 1, not copper 2. Notice that there's a 2 in the molecular formula. But the 2 is there because oxygen had a minus, let's do it the right way. Oxygen had a -2 and copper only had a +1. So we needed 2 coppers. It doesn't tell us that copper is a copper 2. It's just telling us that we needed 2 copper 1s. Hope that made sense. All right, copper 1 oxide is the name. All right, this is the last section and maybe the hardest. Okay, last section, and then we're just going to practice from now on. So polyatomic ions. So again, you need to be on the back of your periodic table. This is not all of the possible ions. These are many of the common ions, and we use this sheet pretty exhaustively in our class. So polyatomic ions refers to ions that are actually a group of elements joined together, hence the prefix poly. So a polyatomic ion is an ion formed of more than one type of element. See if you can find polyatomic ions on your common ions sheet. Can you see where there's more than one element? So just look right at the top, look at acetate, CH3COO -1. That's got a whole bunch. It's got carbon, it's got hydrogen, it's got a few oxygens. That's an example of a polyatomic ion. The polyatomic ions are covalently bonded together. So they're sharing electrons, but they're not neutral. And they need to be joined with something else that's going to make them neutral, that's going to make a neutral compound. So right now they have a charge. So if you look at acetate, it's got a -1 charge. If you look at, let's find another one. If you look at ammonium, it's got a +1 charge. Also notice that they're all written in alphabetical order and that the positive ions are on the left and the negative ions are on the right. That'll help you as you're searching for the different ions. Positives are on the left, negatives are on the right. Okay, so moving on, they're listed on the back of your gold periodic table. Let's see what we can figure out. So polyatomic ions have names that typically end in ate or ite. Remember that when we're just doing regular binary ionic nomenclature, we usually end in ide. IDE. These are the exceptions to the rule, and that's very purposeful. And let me just give you one example. So if you end in nitrogen, so if your element is, your negative element is nitrogen, the compound is gonna end nitride. But if you look over here, look up the words in your negative column, look up the words nitrate and nitrite. Nitrate, yeah, we got both. Nitrate and nitrite. Those are elements that are combined. Those are nitrogens and oxygens combined together. So the ending is really important. It tells us what's in that ion. Is it just nitrogen by itself, or is it nitrogen bonded with other things? Okay, so when writing the molecular formula, you still have to make the charges neutral. So if we look at well, both of those are -1, which isn't very exciting, but whatever. You still have to make them cross the charges. So if a polyatomic ion needs to be multiplied to make the charges neutral, it should be in parentheses. So let's do nitrite just for a second. So nitrite is a -1. What if we combined nitrite with iron 3? So iron 3 has a +3 and nitrite has a -1. How many nitrites do we need in order to cancel out the +3 of the iron? Well, we would need 3 nitrites. So the nitrite is NO2. We need 3 of them. So how do we indicate 3 NO2s? Well, we put the NO2 in parentheses. So let's give an example. When writing the name, do not change the ending of the polyatomic ion, just use it as listed. So let's try this. Calcium bonds with nitrate. Oh, it's an example similar. So calcium bonds with nitrate. Calcium is a +2, so write it Ca +2. And nitrate is a -1, so write NO3 with a -1. Now cross your charges. You're going to need 2 nitrates. So how do you show 2 nitrates? It says cross the charges again, but put parentheses around polyatomic ions if there will be more than one. The molecular formula, when we cross the charges, is going to be Ca, and then in parentheses, the nitrate, and you need 2 of them. So now I guarantee you, I will ask you, in calcium nitrate, how many nitrogens are there? And you need to understand that there are 2 nitrogens and how many oxygens? There are 6 oxygens, but they're together as one nitrogen with 3 oxygens, and then again, 1 nitrogen with 3 oxygens. But in total, there are going to be 2 nitrogens present and 6 oxygens present. So how do we write the name? Just straight up calcium nitrate, no parentheses, no Roman numerals, nothing tricky on that one. All right, let's try one more example, and then one more simple example, and then we'll try a whole bunch. Iron with a +3 bonds with carbonate. So find carbonate on your thing. So iron is going to be a +3 here, and then carbonate is a -2. Ooh, it's going to be all kinds of fun crossing charges. So we've got iron. So iron is a +3. I don't know. I keep doing them on different sides, but iron is a +3 and carbonate is a -2. If I get another carbonate, then I would have a -4 and they're still not neutral. So this is where the crossing of the charges comes in handy. If I get 2 of these, I would have a +6. And if I have 3 of these, I would have a -6. Oh, they neutralized each other. So that's where the crossing of the charges is necessary, or is helpful, I should say. And then how do we write the name? The iron was a transition metal, so you do have to have the Roman numeral, and then you say carbonate after that. So iron 3 carbonate is how you write that name. Okay, this page, I'm not going to say a whole lot more, but it's a good one that you could pause and just look at all these examples. So if you're combining calcium, that's a +2, with nitrate, that's a -1, what would happen? If you're doing lithium with phosphate, how do you cross the charges? This is to help you know. And a few of them you had to put parentheses in. So it's a good one for you to pause and kind of think through and make sure you understand them. And then we're going to finish with doing some actual examples. Let me get this all the way out in the corner there. Okay, oops, I didn't mean to show the answer. All right, so this is Ti and then I, not L, I4. So that's titanium iodide. It's iodine when it's not in a compound, but when it's in a compound, then it's iodide. Okay, the next one, find CO3 in your negative ions. And then it's sodium in the front. Sodium is not a transition metal, so we don't need any parentheses. And CO3 is carbonate, so this is sodium carbonate. All right, do the next one again. It's sodium again. That's easy. What is OH? It doesn't have anything. So OH, find it. It's in your negative ions, and it is called hydroxide. And so that would be straight up sodium hydroxide. All right, the next one, iron. Iron is a transition metal. Let's look at chlorine. They didn't tell us which its charge was. So iron has two possible charges, 2 or 3. So we don't know which one it is, except we do with a little critical thinking. Find chlorine on your periodic table. Here's chlorine. Chlorine's always going to be a -1. We crossed the charges, so uncross the charges. Go backwards. If chlorine is a 2, then the iron must have been a -2. And then the chlorine was a 1, and it goes back up to the iron, goes down to the iron. I don't know if I made sense in that. But cross your charges backwards now, and you can tell that this is iron 2 chloride. And look right below it, same example, only now there's 3 chlorines. Uncross your charges and see that it would be iron 3 chloride. The next one, and feel free to pause me at any time, you guys, if I'm going too fast. If you want to solve them independently, pause, solve them, and then go. Okay, the next one, lithium, and then it's got, lithium is not a transition metal, and then it's PO4, so you find it in the common ions, lithium phosphate. Okay, now we have lead 2, so that tells us it's a transition metal, and then it's going to be a +2, and now we have to find sulfite back here, and make sure you don't mix it up with sulfate. So sulfite, give me a second, sulfite is a -2, and lead is a +2. They cancel each other out. No need for parentheses, no need for extra subscripts or anything. It's just PbSO3. Done. All right, beryllium chloride, find beryllium, find chlorine. No transition metal, no fancy polyatomic ion, straight up cross your charges, done. And same thing with gallium nitride. Now be careful because the IDE ending of straight up nitrogen is nitride. So gallium nitride, cross your charges. They both are the same, done. Okay, everybody, let me know if you have any questions, and that's it. Have a great day.